In this video, we're going to discuss CRA models for integer multiplication reasoning. So we have three different examples, just moving our negative sign around. But again, integers include all of our whole numbers and then all of our negative numbers as well. So our first one we're going to have is 3 times negative 2. Again, we're going to stick to this multiplication structure. 3 is the number of groups. Negative 2 is the size of each group. Okay. So for concrete model, these two color counters are useful. Right? The yellow, we're just kind of saying the yellow is positive, and then red is negative. So here, if I have 3 groups, all right, 1, 2, 3 groups that each have a size of negative 2, then what is my total? Well, I have 6 counters, they're all red, so I have to have negative 6, right? My product here would be negative 6. That's a common model for concrete. For representational, right, common is going to be a number line. So again, I have 3 groups that each have a size of negative 2. Right, 3 groups of 2, right, would be moving to the right, right? A group of positive 2, positive 2, positive 2. So this is just going to be 3 groups, but they're each going to have a size of negative 2. Okay, so then my product will be 6. And then this will just be my abstract model for this one. Is 3 times negative 2 equals negative 6. Okay, so again, thing to highlight here is this, that 3 is the number of groups, and then 2 is the size of each group. So I'll move to another example. So here we have negative 3 times 2. Okay, so again, in that group and size structure, how we want to interpret this is, and again, that negative sign, right, we're interpreting that as the opposite of. Okay, so what this is telling us is that we want the opposite of 3 groups with the size of 2. Okay, so again, part of the reason we use the 2 color counters for these models is we can move the opposite side, right? So what I have right now, what I've shown right now is 3 groups with the size of 2, right? Positive 2 is our group size. So this is 3 groups with the size of 2, but I want the opposite of 3 groups of 2, which would be, again, the opposite side. So then I'm looking at my model. What do I have? I have 6 counters, 6, and they're all red. So again, my product will be negative 6. Okay. So that's kind of how we show that for a concrete model. The number line, the representational model, is going to look a little bit different here. I'll kind of highlight why I want this to show up differently. So again, I'm going to first start by looking at 3 groups of 2, just because the opposite of a group is kind of weird to conceptualize. All right, so I have right here, I have 3 groups that each have a size of 2. That goes 2, 4, and 6. So this is 3 groups of 2. I want the opposite of 3 groups of 2. So I want to be on the opposite side of my number, of 0 on my number line. So I want to be the same distance from 0, but just the opposite side. Okay. Kind of what this number line model will look like. Like that. Okay. So again, we're kind of starting with the 3 groups of 2, and then we're taking the opposite. That's how we're interpreting that negative sign. Okay. And then, just to show a little bit more drawn out version of the abstract model, essentially what we were doing here was without formally doing this, what we were doing is we were factoring out negative 1 from this expression, right? Because we started with this 3 times 2, right? So we made 3 groups of 2, and then we applied that negative sign afterward. Okay. So what we essentially, right, we turned this into, right, first we had 6 yellow counters, or first we were at positive 6, on our number line. Then we applied that negative sign for that opposite reasoning to get to negative 6. And then the last variation that we'll look at is just going to have two negative signs in there for both multipliers. Okay, so this will be kind of a combination of both the previous ones that we looked at. All right, so we want the opposite of 3 groups that each have a size of negative 2. So we're going to start with 3 groups that have a size of negative 2. So 3 groups each have 2 red counters in them. That's 3 groups of 2. I want the opposite of 3 groups of 2. Alright, so I need the opposite side there. So now what do I have? I have 6 yellow counters. Yellow counters are positive, so I have positive 6. Okay. So that's our concrete model. And then again, number line will be the representational model. Again, I'm going to start by doing 3 groups of negative 2. All right, so that's 3 groups of negative 2. Right, these each have a size of negative 2. But I want the opposite of this. Right, so I need to go to the opposite side of the number line, so the same distance for the opposite side. So the opposite of negative 6 is positive 6. And again, for the abstract model, all that I was doing was we factored out one of these negative signs here from the 3. All right, so we started by making 3 groups of negative 2. So that gave us a group of negative 6, or a total amount of negative 6, like on the number line there, or those 6 red counters at first, and then we want the opposite of that, and the opposite of that is going to be positive. Okay. So concrete model is pretty common. It's going to be those 2 color counters. Again, since we can do the opposite side, representational, a common one will be the number lines, just since we can do the opposite as well. And then for abstract, will just be the equations. Just real quick, I want to show another representational model. I'll show it just for this one. Right, if you want it to better align with the kind of set model of those 2 color counters, right, we can just do little minus signs, or you can put a little circle and then do a minus sign inside of those. Right, so this is 3 groups that have a size of negative 2. I want the opposite of this, which just means I want the opposite sign. So then this will be turned into, so again, you can use just the symbols themselves, or right, we can kind of make them more look like our counters. And that'd be another example for representational model.